Hi everyone, this is Rajeshwar from ECB section. My topic is backscatter modulation for wearable devices. Let's see introduction about it. Small computing devices are increasingly embedded in objects and environments such as thermostats, books, furniture, and even implantable medicine devices. A key issue is how to power these devices as they become smaller and numerous. Wires are often not feasible, and batteries add weight, bulk, cost, and require recharging or replacement that adds maintenance cost and is difficult at large scales. Backscatter is a method that uses an incident radio frequency signal to transmit data without a battery or power source. It employs passive reflection and modulation of the incoming RF signal and converts it into tens or hundreds of microwatts of electricity that can be encoded for data communication. It differs from other wireless communication since the communication is of duplex in nature. That is, both the sender and receiver cannot transmit simultaneously. The the main advantage of backscattering is that its low energy requirements and low complexity of development. This is about the introduction of backscatter modulation. Let's see the ambient backscatter harvesting power from thin air. A new system of wireless communication allows devices to interact and send data from one to another without having any source of power. The system is based on the new ambient backscatter technology, which practically harvests all the existing signals in the air and converts them into power for communication devices. University of Washington researchers created this new system which absorbs all the different kinds of transmissions all around us in the air from radio waves, TV and cell signals to mobile networks and Wi-Fi and transform them to both a source of electricity and a medium for battery-free communication. Basically, prototype devices using this technology are equipped with antennas to pick up the signals and reflect them back, and forth other devices equipped with similar antennas then intercept and decode the signal and send a response, allowing full communication without any exterior power source and without any human intervention. See the architecture of the backscatter communications. A backscatter, a basic backscatter communication system has two main components, tags and a reader. Tags are encoded with a unique ID and are affixed on moving objects so that they can be identified or tracked. Readers are the intelligent part of the system that are installed at tracking points to read information from tags when they come into range. This is the backscatter architecture. You can see in the picture left side. Here is the reader sends the signal, and from the here is the passive backscatter signals from the passive tag. Tags are passive nodes that don't have their own power source. Here these tags have any power source. The reader always transmits a signal as a signal tone sinusoidal continuous wave regardless of whether it has bits to send or not. When the tag has data to send, it harvests the signal received from the reader to get the power to run. To send bits, it modulates the incident signal to encode its data and then reflects a fraction of the wave back to the reader. This method is called backscattering. This is a block diagram of backscatter device. Here is we have an antenna. From antenna is RF signal is generated. RF harvesting and power management is sent to the digital logic and then to the indicator LEDs. From that again it is reflected to using buttons to the again digital log then sent to the transmitter from the TT sent to the reader. The transmitter, receiver, and the harvester are all connected to a signal antenna and use them as same RF signal. The transmitter and the receiver communicate by backscattering the ambient signals. The harvester collects energy from the ambient signals and uses it to provide the small amount of power required for communication and to operate the sensors and the digital logic unit. The researchers tested the ambient backscatter technique with credit card sized prototype devices placed within a several feet of each other. For each device, the researchers built antennas into ordinary circuit boards that flash an LED light when even receiving a communication signal from other device. Groups of devices were tested in a variety of settings in the Seattle area, including inside an apartment building, on a street corner, and on the top of the parking garage. These locations ranged from less than half a mile away from the TV tower to about 6.5 miles away. Three keys for ambient scattering. It takes advantage of existing RF signals so that it does not require any development of the special purpose power infrastructure. It has a very small environmental footprint because no additional energy is consumed beyond that which is already in the air. Ambient backscatter provides device-to-device communication. Uses of backscatter communication. Backscatter is extensively used for EPC RFID communication systems. EPC stands for Electronic Product Code and RFID stands for Radio Frequency Identification. It involves application of radio waves to read and capture EPC stored on tags affixed to objects. RFID readers are installed at tracking points and can read EPC from tags when they come into range. EPC RFID system is used to check identities and track inventory, assets, and people. RFID tags can be attached to the variety of objects like cash, clothing, baggage, parcels, and even implemented in animals and people. Its uses are about backscatter communications is providing to be indispensable for development of Internet of Things, shortly known as IoT. IoT requires a large number of sensors that may be installed in remote or hazardous environment where batteries charging is extremely difficult. Backtracking allows IoT IoT nodes to transmit data by modulating and reflecting the incident RF signals from readers or other receptors. Future applications. Smart sensors could be built and placed permanently inside nearly any structure. They then set to communicate with each other. For example, sensors placed in a bridge could monitor the health of the concrete and steel. They send an alert if one of the sensors picks up a hairline crack. The technology can also be used for communication, text messages, and emails, for example, in wearable devices without requiring battery consumption. Disadvantages are it requires no additional battery or power outlet required, function anywhere and with no maintenance, no pollution, compact in size, can be used for home monitoring. The tech could also be used to allow smartphones to send text messages even if their battery is dead or to tag various items such as keys, wallets, and phone to transmit their location if they are lost. Design avoids the expensive process of generating radio waves. Devices communicate by backscattering ambient RF signals. The conclusion is about is ambient backscatter, a new form of communication that provides connectivity between computers out of what is essentially then thin air. This technique, TV signals, and other sources of RF signals serve as both the source of power and a means of communication. Because ambient backscatter avoids the maintenance heavy batteries and dedicated power infrastructure of other forms of low power consumption. Example RFID. It enables a BV of new applications that were previously impossible or at least impractical. Ambient backscatter provides a key building block that enables communication with no restrictions except the existence of ambient RF signals. Among pervasive devices which are cheap and have no zero maintenance. So thank you.